So this is going to be a short video on how to detect the sequence 1101. This is an example from lecture 14. So let's begin. So we want to start with state 0, and that holds nothing. We want to then have an input of 1, output of 0, because we're entering in this first digit here. We get to S1, and now S1 will hold the value 1. So that's like the current status we're at right now. So now we want to enter in another 1. So now we're like right here, we've entered in our first 2 bits, and we are now at S2. Then we want to enter in our third bit, which is 0/0. And now we're at S3. But we want to use the least amount of states to represent this diagram. So we have to figure out where this last 1/1 will go. The reason why the second number here is a 1 is because that's when our sequence will be detected, because we want to detect 1101. So where do we cycle this input back in? I forgot to write down here, but state 0 will hold 1, 1, and then state 3 will hold 1, 1, 0. I like to think of these red numbers as almost like a status that we're at right now. So like it's our status to completion. So like when we're at S3, we've already like entered in 3 numbers and we're just almost waiting for the last number. So currently we're at 1, 1, 0, and we want to enter in a 1. So what I like to do is I like to remove the most significant bit from the sequence that we're at right now. So 1101 doesn't match any of the states that we have right here, whether it's S1, S2, or S3, or even S0 if we have to. So we remove this digit here. So now we're at 101. Does 101 match any of these numbers here? It does not. So we can remove that as well. So now we're at 01. 01 also does not match any of our current states that we have right now. So we can remove this. But we have here a 1, which matches state 1. So what we can do is we can have an input of 1, output of 1 here. So this will go back to S1 because we're almost reusing the last number that we have in a way. So let's say we were to put in 1101. We can also enter in 101, and it will detect this here and this here. So we don't have to have that extra 1 because we want to use the least amount of states. So this right here is the backbone. Now we want to do the states that are not progressing our sequence. So let's say we started entering in a 0. That doesn't complete our sequence or even progress our sequence. So we're at state 0, we enter in a 0. It will have to go back to itself because state 0 holds nothing. So now we're at state 1. State 1, we currently have a 1, but we want to enter in a 0 because the ideal situation was to enter in a 1. So we're at 1, 0. 1, 0 ruins our sequence because we can't reuse this 0 here in any way. So state 1 with an input of 0 will go back to state 0. The input is 0, output is 0. So now we're at S2. S2, we see we hold 1, 1 already, and then the next number that we normally would add is a 0, but we want to do the unideal situation. So that would be an input of 1. So we have 1, 1, 1. We can actually reuse this mess up in a way. This here can be the start of our sequence again. So we don't have to go all the way back to state 0, because state 0 is like where we completely mess up our sequence. But we can reuse the last mess up, so we can stay at S2, the input of 1, output of 0, because we're not progressing our sequence. Progressing our sequence go this way, and we're not ruining our sequence in a way, because that would be going back to a smaller state. We are staying in the same state because we aren't making any progress in a way with our state. So now we're at here, and we have 1, 1, 0, and the ideal situation was to enter in a 1, and it unlocks our sequence. But we want to do the unideal situation, which is a 0. So I can do the most significant bit trick where I remove each front number and see if it matches with any of these states here. So we can start off with 1, 1, 0, 0. We can look at the 1 or look at the whole thing and see if they match any of these states, which does not. So we can remove the 1 here. Now let's look at 1, 0, 0. That also does not match any of the states. Then we have 0, 0, which also does not match, and neither does 0. So this is the case where we can't even reuse any of our mess ups. So we'll have to go all the way back from S3 to S0 with an input of 0, output of 0. I hope this helps. Bye.